Kelly, and what we're going to try and do here is a bit of a follow-up to the fieldwork stuff that you saw in the last video. In that video we were out in the field, we were collecting data using our quadrants. Now what I'm trying to do here is take some of the data that we collected, or I collected, soil samples that was associated with each of those quadrants. And then what we want to do is to test those to see exactly what is happening to the pH levels. Because what we were testing was for biodiversity. We were looking to see how biodiversity increased as we went from the sea through the marshland inland, or from the sea through the dunes inland. And what we want to test is to see as well, does those changes in biodiversity change the soils? And in theory it should, because as your plants develop, as they grow and become more mature, well, eventually they will die, they will break down, and they will add biomass to the soil, changing that soil from very salty and sea-like, because it's influenced by the sea water, through to the types of soils you get in your garden. So that's the aim. And there's plenty of ways you can do this. We have our soil samples that we'll look at in a minute, but if you were doing this for your coursework, you could use something like this, a little testing kit. And you can buy individual little testing kits in garden centres often to test the pH and the quality of your soils, or you can get ones like these which are a little bit more scientific, and you get samples, solutions rather, that you use with this, that you dilute and you put this in. And it's a little bit complicated for now, we're going to keep it simpler, but if you're going to do your independent investigation, then you can use this for your independent investigation at another time. Or the simplest way is just to go for one of these. Some good old-fashioned pH paper, which I'm sure you used before, and just to kind of make sure that it's going to work for us, we're going to do a little bit of a test. So I've broken out a couple of little slips from it. And this is just some tap water, which, as I'm guessing you know, should go a lovely pH 7 colour. pH 7 is neutral, so we're looking for that to go green. And you just match it up to these colours, so it's kind of turning into a greeny colour between those two. But just for fun, we're going to test this as well. So some lovely lemon juice that I picked up on one of my trips to Sainsbury's. And I'm hoping you can guess that lemon juice, apart from going everywhere, should be slightly acidic. Now I've made a right old mess of this, but here's my lemon juice. Just going to put that on the top, and I'm hoping you can see it's going really bright pink already, so really different to the previous one. And obviously lemon juice is acidic, and we can see there that colour ties in beautifully, and that's about a 3 or a 4. So if I take those two, I'm going to show you these again. These are our two testers to make sure the strip works. The pink one was the lemon juice and the green one was the tap water. So nice kind of pH 7 for the tap water and about 3 or 4 for the lemon juice. Okay, on to our soil samples. Hello! So these are our soil samples. I've got two very different bags. This was from the marshland, and you can see it's kind of browny. It's got some bits of vegetation in there too. And then that is from the sand dunes. You can see it's a lot sandier. Go for this one first of all. Box D collected this when we went out on the Tuesday, and what they've done is they've put some beautiful labels in here. So I'm going to open this one up. It's been sat in my dining room since then, hoping it's not too smelly. So that is sand sample 5, that we've got. And it's a little bit dry. There's not much in there at all really, just some veg that we've got there. And if it's a little bit like that, if it's a little bit dry, we're going to need to add some water to the mix. Smell. So, a little bit of water, gonna put that into there, and just, if we'd done this at the time, if you do this in the field, you don't need to add water, but just adding a little bit of tap water to that one. So we've got something to mix together and something to test. So we're trying to get that kind of wet, muddy bit from the bottom. And then just down near the roots, down near the mud, I'm just going to dip in the pH paper, giving it a bit of a squidge. Oh, look at that one. Okay. Let's try another one. Okay, so again, quite muddy. And this is sample 7. And let's try this one without adding any water. Yeah, there's enough moisture in that one. You can see it's made it wet. It's not really started to change colour at all, so we'll give it a minute and see what happens. But that's sample number 7. So I hope you get the idea. I'm going to continue and do all the rest, and I'll put them on a sheet for you, and hopefully you'll be able to see them all. So I'm going to line them up. It'll make sense. I'll show you the piece of information in a minute. But you'll see them all running from right near the sea edge, right inland, and hopefully we'll see some changes. It's just starting to go a little bit darker green on that one. Obviously this is not perfect, it's far from it, and if you do this for your coursework, your independent investigation, you'll be doing this in the science labs. So you'll have, instead of tap water, beautifully distilled water, and you'll have much better area to do this all in. But you get the idea, it's just testing the pH and looking for changes. Hello, so welcome back. I've just finished doing the pH testing, and it's actually quite interesting. What I forgot to say was when we collected the samples, we ran out of plastic bags. So for the second location, we didn't manage to do every 5 metres, we did every 10 metres, and even then I've only actually got 4 samples in that group. So let me show you the data that we have got. There we go. And obviously we have our lovely little record to go with it. Don't worry, I'll put pictures of these with the video on eBrock for you to have a look at. And all I wanted to say was there's a lot that we can think about with these. Clearly there is some variation, so that's a success. We can see changes, but it's not vast. Those colours don't change massively. And if we particularly look at the marshland, where we do have our every 5 metres and we've got those changes present, well, it's not massive swings. You're not talking from, you know, pH 4 to pH 7. It's much more gradual, and actually we'd expect that. So we do have variations. Is it perfect? No. Particularly if you look at quadrant 3 and 4, we didn't get much colour change there from the original yellow with the pH paper. So that would be something I would need to retest. And if I look at some of the ones which did react strongly, particularly number 9 and number 5, those were where the soil had quite a lot of vegetation in it. And having left those soil samples in my dining room for 6 weeks, I think those vegetations had started to decompose and might have actually started to influence the soil more so than it would have been. So that's a weakness. It's a weakness, you know, having not really done it quickly enough, and perhaps not being able to do it in the field, having the soils decompose a little bit. And that actually is something that would happen in nature, but it's probably been emphasised. So I think I would have quite a few anomalies. And if I was to do this for my coursework, I would definitely want to repeat the experiment several times to see if I can get much more valid and more accurate data sets. So yeah, it worked. It showed me some changes. How reliable are those? I think there's a lot of weaknesses going on here. You know, lack of samples for the dunes, time change over which the samples have been sat and decomposing. Some of them were a lot drier than others, where you did need to add water. That water did influence it a little bit. So not a great experiment, I'm afraid. Lots of weaknesses, but that's okay, because where you've got problems, it means that you can evaluate those weaknesses later on when you write your evaluation. So flawed, does show us some changes, but lots to think about and to evaluate. So using the data that we've just collected from doing our pH test, we're going to try and draw a line graph, but rather than having a straightforward axis, we're going to try and do a t-axis. So what that means is we're going to have a line in the middle, and this is actually going to represent distance. So I'm going to put D for distance, and here we're going to have our transecting line. We're going to start with pH of 7 in the middle, because that's our neutral pH. And what we're going to do is we're going to try and have very subtle ranges. So we'll probably just go up, you know, to pH 8 and pH 9 there, and then pH 6 and pH 5 there. And then this is just our distances. So we're going to start at the C with quadrant 1, and then this will be quadrant 2, and then quadrant 3, and we're just going to plot it as a line graph. So if at quadrant 1 my pH was 8, I'll do a nice little cross. If at quadrant 2 my pH was 7.5, I'll do a nice little cross there. At quadrant 3 it might have been pH 7.5 still. Quadrant 4 it might have been, say, 7, and then by the time I get to quadrant 5 it might have gone to, say, pH 6. And keep going. I've run out of space here, but adjust your axis or do this on Excel so you can cover all 10 of the quadrants. And once you've done it, just join them together in a nice line graph like that. Can you do 2 for me, please? Can you do on the same axis the pH for the marshland and the pH for the dunes, so that we can then compare the two? Just do them in a different colour.